Hi, hello, Hemant.
Hi Shanti.
So you're doing first Terraform demo, right? Terraform
Correct.
script demo
This is my first
on
Terraform demo.
AWS. Sorry, Azure, right?
Yes. On
Uh,
Azure, correct.
yeah, please go ahead.
Yeah. Thanks, Shanti. So today I'll walk you through one of the scenarios that we can perform on Azure portal, which is creating a VM on Linux and deploying Apache 2 server. So the same scenario, we will try to automate it using Terraform scripts, and I've created a module for it. So we'll go over that details. As part of this, we'll also look at the AI prompts that I have utilized for generating the configuration files for Terraform and how we can reuse those as part of this deployment. So let me start. So these are the prompts basically I have used that I picked up from Gemini, from ChatGPT, and also Perplexity. I've seen scenarios where some code that has been provided by ChatGPT is not complete, so I had to find other ways to find those missing resources, where to add those resource types as part of the modular declarative coding. So let's look at those prompts, and then we'll jump into the slides, and we'll perform creating VM on the portal, and then we'll repeat the same, automate the same using Terraform. So this is our AI script that's generating a code from Terraform. So I provided a AI prompt saying provide details of infrastructure as code Terraform script to create a Linux VM and on Azure and install a web server Apache 2. So it gave us some scripts that I have used. And once I started using these scripts, I've tried to understand the best practices, how to keep those configuration files separate, what are all they needed. So while having all those in place, then I started trying to execute those configuration files. That's when I came across different errors about custom scripts, how to resolve. Basically, we have, once the resource has been created in this case, which is the VM, then we also need to execute some batch script on the VM using shell script. So I've tried to understand how we can execute those. So I thought maybe custom script is what needed. Then later I came up with um, provisioners that help us execute those batch scripts on the VM. So you can see the prompt slowly changes. It provides some steps, um, some configuration details, what commands to execute on the Terraform once the file is in place. So all those details are here. It also includes some troubleshooting that I came across as part of trial and error. You can see I've used remote executor. I replaced that settings versus remote executor on the provision. And some also I've come across some challenge while basically configuring the virtual machine. So the VM was created, and but when I went to try connecting, it was not connecting because the configuration failed. So there were some missing parts to the code that was provided. That's when I jumped into Perplexity, tried more research on what is the missing part. So we'll go over those troubleshooting steps later, but I just wanted to show some of the screens, resources that I have used. This is from ChatGPT. This is from Gemini, about how to set up Terraform configuration um, with the help of provisioning, where is it used. So all those details are basically in here. I won't go in detail, but we can quickly jump onto our slides. Okay. So one is we already see the first one. Basically, second one we have seen second prompt as well. Third is when I started getting errors, how to manage existing resources, when to use those public IP, how to connect or assign a subnet to them, how to add an NIC to those existing VM. There are some timeout issues that were happening while I was running the Terraform commands. We're trying to establish a connection to the VM, and I had some timeout issues. It was retrying. Some prompts about Git policy, even though I wasn't um, made any just-in-time configuration, but the response from the AI tools were directing me to JIT. So I did some research, then realized it's no way related as part of this automation process. So then I also looked into allocating some regions, specifying what regions to choose. So what is the proper way to choose from the list of locations? So we have East, West, US. So what article I can use? So that I came across Azure Image website, and also there's one Azure Cloud Prompt that will basically list all the available active locations that we can use to host our VM. And then we went over this NIC security. Okay. Yeah, 10. So from prompt 9, 10 is where it took a lot of time because I had a missing network security group ID that was not part of the output I got from the scripts. So when I realized that, I'll tell once how I went to this group. I didn't be able to identify that the group ID was missing later. So I just wanted to highlight them here. Okay, so what are the prerequisites for this? The scenario today is basically walk through the process of manual creation of VM, and then we'll automate. And the prerequisites would be user should be having access to the Azure portal. And I have installed Visual Studio 1.9 on my local machine, and also installed Azure CLI with version 2.64 and Terraform, which is 1.9.5. So I have all these configurations set up and ready for this demo. So what is the agenda for today? So we'll create the VM through first Azure portal and verify that the web server Apache 2 is installed, and we can see if it's up and running. Then we'll perform the same steps using Terraform scripts. I've created a module for this, and we'll execute that module. So, and as part of this step 2, we'll go in detail about how to add the resources, where to add those variables, how to execute the Terraform scripts to run the execution and provide and generate those resources for us. So we'll go ahead. Okay, before jumping into automation part, let's quickly go into the Azure portal, and we'll try the manual process first. This is from yesterday, so I want to delete this resource group that got created yesterday as part of this automation process. Let's go into virtual resource groups. Okay, I'm gonna delete this. While this is happening, I can delete a VM that groups that is not will overlap with our automation process. So I'll go ahead, create one VM, so resource group. I'll give this name as say Linux AP, which is Apache RG. Okay, I'll go ahead and create. Okay, now let's create a VM for this resource group. I'll give any, okay, resource group, XPM APRG. Okay, this is fine. Name will give, this is for Apache to run. So I say VM. Alert zone will keep it minimal, no infrastructure redundancy. It will be on Linux OS, so I'm picking Ubuntu, which is already populated here. Size, I'm going to keep it as it is. I'll run a Azure Spot to keep the price cost low because I won't be running it for a long time. I'll be deleting right away. SSH key, I'll go with password to log in into this VM. Okay, all out ports would be SSH, and also I'll give HTTP so that once the Apache is up and running, we can launch, we can try to access through the IP address and verify that the deployment is proper. Provide some details, we'll keep this minimal. Delete VM, okay. I'll go ahead, let's go to networking settings. Everything remains the same. Delete IP and VM after the IP and NIC after the VM is deleted. Okay, I'll check this. No load balancer at this time. I'll go ahead, nothing changes in management. You can choose, this is a best practice to keep auto shutdown, especially for load environments. So I'm going to checking that. Enable OS, so nothing changed here. So this is where we can actually provide those scripts to update the package tools and also install Apache from here, but we won't do it here, but we will go and manually enter once we connect to the VM. Tags, I'm not giving anything as of now. So we'll go ahead, perform some validation. Validation is passed. So here you have an option to download the ARM templates. We'll look into that in the later demos. We can download if you want. If not, you can go ahead. Let's download one. Later we can take a look if while deployment is happening. Zip file, okay. Terraform, okay. Now I'll close. We'll create the VM. While this is happening, okay, let's see if we can look at those template. Okay, you can see all the dependency resources are being created. Deployment is in progress. So I'm extracting the ARM template as well. So you can see it has two JSON files. One is for parameter and template. Okay, deployment is complete. So we'll come back, we'll resume this. We can see there 6 resources. One is additional resources because we set up the auto shutdown option. So it also created one resource that will take care of scheduling part. So let's go ahead, connect to this resource. It also gave assigned a public IP address. We'll try to launch it here. Okay, I'll go back. Now I will connect to this VM. Configure and connect. So because we use the username and password to connect to this VM, there's no public private SSH key that got generated. So once we have that key, that is the best practice to connect, especially when on connecting to VMs that are having a production environment. So it's always better to use key instead of password. That is more secure. Okay, now the Azure CLI is open and it will generate an Azure command to connect to this VM. I'll say yes, it's saying, okay, let's connect. Yes. So when we actually connecting through Terraforms, we will see some of the commands having -yes. That means we're saying any request from user asking a permission. By default, it's an yes. Okay. Okay, let's see. Okay, it's running some updates. Let's see. Okay, let's go and execute some of those commands. Now we are able to connect to the VM. Let me grab those commands from here. Sudo get update. It should allow me to copy. Okay. Now we will install Apache 2 on the server. So all the dependency libraries and Debian files have been unpacked and installed. Okay, the installation is complete. Now we'll basically bring up this web server, Apache 2. So now we can go ahead and basically see the status of this app server using sudo systemctl status Apache 2. You can see the status is active and up and running. And let's see, is it because we have allowed permission to connect to this VM through HTTP port. We'll try if that is also ready, accessible from browser. Yes. Okay, so this is the manual part. So now we'll go execute a similar process by from the Terraform. So before that, I'm going to go ahead and close this connection. Exit this. Okay. I'll stop this VM. I'll go to resource group and we can delete. Okay, while this is deleting, we can go ahead and look into our Terraform. Okay, so on the left, let's look at why we use Terraform is basically to automate the process of creating resources on any cloud server. So Azure already provides one um, um, application like Azure Resource Manager that is very specific to Azure, but Terraform is more it's a cloud independent application where we can automate either Azure or AWS or Google cloud services. So this is this is a declarative process of creating resources. That way, it keeps the code very simple and helps us in having reusability of creating the similar resources in future. So as part of this demo, I've created a few files. So all the files here basically end with TF, which is Terraform, and main is a file where basically most of the Azure Terraform configuration script is written, and I've created two environmental files, one for dev, one for QA. So I'm consuming something from this file when I'm with a variable that is related to resource group name. So this is the group name I'll be using um, to create this VM. And you will see this resource group name will be called multiple times in creating other resources where the group name is required. You'll see it as a variable so that we are not rewriting this. So I'm use this as one of the examples to show how we can use variables. QA TF is not something I have used as part of the demo, but it is there. And we can look at some another TF file, which is variables, where we have created a resource group name variable that we saw in the dev, which is of type string. That means it can take alphabets, numbers to store this name. And if we haven't provided any name to this resource group, by default, we have given a name that would be using if the script runs where we haven't provided any explicit name, this will by default pick tfvm1. Now we'll look into the main configuration Terraform file. So here we'll see the first code snippet has a provider, which is basically telling the Azure resource manager. So this is resource manager is what basically takes this script, and we will be connecting to the Azure via the command line interface, which is already installed. And once we provide the subscription ID through which basically it will authenticate that I'm the proper user, and please allow access to make a connection to the Azure portal to create the below resources. So features, you can customize some details. So you can provide details like tenant ID. All those additional details can be provided as part of this provider. And next block of code is basically um, um, talking about what resources we are actually looking at. So now we have all these written in the slides. So we'll go to the slides now. We'll go walk over those resource steps from here. Okay, so we have three files, Terraform files that we looked at. The first one is basically provided the name of the resource group. And then there's a dev file, which basically is every environment specific. If you want to maintain multiple environments and save data that is specific to the environment, you can use these files. And the third is the configuration file, the main TF file. So now we are looking at a group. So this is how the we interpret this code. So first, each resource type has a specific reserved keyword. We can see the first double quotes is referring to the resource type, and next double quotes is basically referring to the name for this. So the first line is basically for the Terraform to understand what kind of resource we are asking to create in the Azure portal. And what's within the brackets is basically referring to the parameters that are currently existing in the Azure environment. So these names that we are providing will be given to the resources that will be created in the Azure cloud environment. So in the first case, name, I could have written Linux Apache. So instead of that, I am showing that I already have that variable declared in that variables.tf file. So this name will basically read the name of that resource group from this variable. So location, I could do the same for location instead of hard coding. So I just showed one as an example, but going forward, most of the demos will try to have the best practices for the Terraform demos. Similarly, you can see that that took care of one of the resources in Azure. So now we'll move into the next resource, which is for creating virtual machine named TFNet. And it will basically also link to the previous resource group that have provided. You can see there's also resource group name, and we are reading it from resource group here. There's also address space, basically telling here that the first two portions of address is the address, and the second two portions is for the range of addresses. So in this case, when the CDAR is /16, that means almost 62,000 different IP addresses can be assigned to the resources as part of this address space. So next, we look into another resource, which is for subnetting. And here we gave a name to the subnet. We are asking them to read the name from the resource group. Then we are giving also a name to the virtual network as well, and address prefix, which is /24. That means here in this case, we'll have around 256 available IP addresses range for this subnet. Okay. Next, we are basically assigning IP address to this virtual machine and all those details. And we are saying, please generate a static address, which means tomorrow when the VM is basically booted, rebooted, shut down, you will see that IP address will be remain intact if it's static. So that's what it means. Now we look into NIC, which is network interface card. We gave a name. We're telling Terraform that use this resource to create a network interface card, and it will be, this is the location, and it should be part of this network resource group. Further, we are giving a configuration for this network interface card, telling which subnet it should be part of, what is the IP address. It can be dynamic, how we're gonna generate, or can we hard code the IP address. In this case, the best practice is to let it generate so that tomorrow there won't be any conflicts when there will be multiple VMs creating. Now, the last step, we are basically assigning or associating the IP address that is generated to this NIC card. That way, once the deployment is complete, the VM will be accessible through internet. So continuing in the same main Terraform script, now we are basically looking at network security group, which basically is like the firewall that checks the traffic that is coming in and out. So here we are telling create a network security group with Ubuntu NSG as the name, and for this region, for this resource group name. And you can see at the bottom, we used two ports, opened up two ports, one for SSH connection using on the port 22. And also there's you will see when we execute that Terraform commands after apply, you will see that the connection gets established through SSH. And once the execution of this Terraform script completes, we will also verify that the app service Apache 2 will be also available on internet using HTTP protocol on port 8. So we'll verify both as part of this demo. Now, okay, this is the security group association that was missing in one of in the AI scripts. So I was able to identify through Perplexity AI that this is something that is needed. So what happened was the VM got created while troubleshooting, and the configuration, basically that validation step that happens once the VM is established, that was failing. So I couldn't understand why it was failing. So I tried to compare the steps I manually created, and I started comparing each page that I created one test VM, and I compared the NIC with the NIC that the Terraform created. Then I compared NSG with the test VM with NSG that got created using Terraform. So I realized that there's one um, option where the NIC should actually connect both to the VM and also to the NSG. So from the Terraform script, I realized that that connection to NSG was missing in the NIC. So which is this group association resource that is required. So once this connection or resource got added, I was able to make and resolve that issue. Then now we are looking at resources to create the VM. We're giving the allocation size. We can also find these details on the Azure command line interface as well, using the virtual machine image website also. So once the details of the code snippets provided had outdated data, so obviously I had to find what is the latest network interface, um, what is the latest VM size I can provide, what is the OS image name I can use. So like those details has to be updated from the code snippet. And configuring OS details as well, like SKU was as an outdated name. The offer is basically either you can pick it up from the cloud marketplace, which has these details of the OS you choose. Publisher details can also be picked up from there, from the subscription or even on the marketplace. So I got those details. I updated these resource details as well. And here you're basically telling further configuration details about what's the purpose of this VM. Do you only use for reading, or you'll read and write? Those permission level details can be provided here. And I've seen where I've used capital letters, and the validation was throwing errors, so I have to change some of those. I try to practice those best practices as I was coding, so I could learn some of them, and I was trying during those execution and process, so I try to implement them whatever I can. And next resource is for storing your login credentials. So the best practice is either for lower than one, but at least you can save them um, in a in your variable file. But ideally, if we can use Azure Vaults, or we can store these encrypted data in Azure blobs. That would be a best practice to do. But as part of this demo, I'm just having it here. Um, the other thing is during also the Terraform script execution, you will see in the output what all resources are being created, and it will be echoing those output on the command terminal. So here you are basically saying when specific to the password, please don't show the details on the execution path. So unlike password, if you have more other sensitive details, we have some um, we can use resort keywords sensitive, and we set it some variables to true. That way we won't see the details as well. Okay, now once the VM is deployed, we need to run some scripts on the VM after the connection is established. So this provisioner basically allows us to connect through SSH. And we are basically saying use this username and password basically to connect to the VM, and also keep trying if the connection fails within if connection timeout is you are given as we have given as for 10 minutes. So basically keep trying until 10 minutes before giving up. And once the connection establishes, we have seen what scripts we will be executing on the VM. So here in the anything under inline code is all related to the script, and we are saying that if you come across or if the test script fails, and it gives an exit code which is not 0, please output that in the command line. So that's what it means. And set X basically means print each command before running the execution. That way we know where the execution flow is, and we should be able to immediately catch the errors that were happening. So once this is done, we also provided a tag to this script saying that this script should be part of development environment. So now we can verify the same. So another option we have also given is we haven't executed this as part of the manual creation, but enable is basically we are saying that tomorrow if the VM, Apache VM, or the Ubuntu VM gets restarted, rebooted because of any domain updates, this should automatically bring back the Apache server as well. So that's what it means when you say enable. Okay, so I think now we can go ahead, see those steps. So once we logged into, once we open these Visual Studios, we already have the CLI installed. So first we will help the Terraform to identify to which subscription ID we will be connecting, and how and where it will generate those resources for us. So to do that, we will log in using Azure login command, and from the output, we'll select this subscription ID that's highlighted. We have only one in this case. So once that validation happens, we will initialize the Terraform. So when we say initialize, we are saying that the authentication is done, but please prepare the uh, backend resources for us before we execute our command to deploy these resources. So that is what it means initializing. So once that is done, um, we will run a command called Terraform validate, basically saying identify if there are any syntactical errors in the code. That way we don't have to run the apply command, which will execute and then give us some syntactical errors. Rather, we can try now, and uh, we can save time that way. And this is much faster to identify syntactical errors now rather than during the execution phase. So you can see now the validation is successful, the configuration is valid. So a refresh is command, something that I want to share is tomorrow if there's a need of moving our resources from one VNet to another VNet, that way the resource won't be available when you try to execute the scripts. In that case, we perform this refresh so that the state plan, we will look at it later, has the updated information. So we won't execute refresh as part of this demo, but it is something that we can discuss as part of the demo. So once the initialization happens, we will basically use Terraform plan, telling Terraform to basically show me what is your execution flow, what all resources will you create as part of this script. So here I have given dev.answer, also basically asking Terraform to also show the output of what you're planning to execute for future references. So once that is done, basically the plan will show how many resources will be created, if there are any to be destroyed. So you have to look out to those resources, and also you see how you intentionally creating any removing or destroying any resources. That way we know we are not changing others code tomorrow when we are working in a group environment. So next would be basically apply is basically deploying the resources. So from here Terraform will connect through the CLI to the Azure portal and create those resources for us, which is the virtual machine and dependency resources, and the execute the commands. So I try to capture some of the screenshots for this apply, because it's a pretty lot of details in those execution. So we'll just go over some I feel that might be helpful. So this is a screenshot basically on the plan side, telling what all resources will be created before it creates. That way we know what to expect from the output. So you can see at the end of that plan, you can see it's showing that 8 resources will be added. and no changes, and 0 to changes and 0 to destroy. Okay, so this is what you wanted to verify before you apply the changes. So once this is done, basically once you apply, it will basically ask, do you want to perform this action? So you say enter yes, and now the resources will be created. It will show also how long it will take you for creating this VM. Um, once you can see from here, now it's after the VM is created, it is trying to connect to the VM via SSH, which because we gave that security, set up a security rule to connect to VM. And you can see it's showing the username, IP address, but not the password. So that's the feature that we have. We have enabled not to show the password sensitive information. Okay. Now at the bottom, you can see it's trying to now execute sudo apt get update. Here also I have come across issues where I think the steps are so fast that even before the VM is ready, it was trying to update, and it was throwing some errors that update was failing. So I have given, as part of the demo, I've given a couple of times to basically run the update so that if it fails one time, it can try executing that command again. Okay, now you can see the scripts are actually running, and at the end you can see the Apache 2 server is also basically deployed. You can see apply complete, resources 8 added, 0 chain and 0 destroyed. And you can also verify the same web server is up and running and accessible from HTTP port as well. Okay, so now let's go and try to execute the same from the Visual Studios. So this is the path. So you can see this is the path of this module where I have these files. So on the terminal, if you basically go to the terminal and say new terminal, that would open up this below command prompt. So you can say now Azure login just to see that connection is still there. I'll pick my connection, continue. I'll say I have one subscription, please connect to that. Okay, now the connection is established to my Azure portal. Now I'm asking Terraform to basically initialize, bring up all the plugins that are required, set up the backend stage. Okay, initialize this update. I also want to validate if there are any, by mistake, some typos that can be identified now. Okay, there's no issues. That's good. So now we can go ahead. Let's see, we can use that plan. Okay, so you're saying let's show me the execution plan before you create these resources. So the plan would basically output on this dev.answer. So once this is complete, we can look at that output. You can see as part of initialization, there are other dependency files that this will create, like Terraform HCL file, log file. So those are all dependency files that we'll be needing as well. Okay, now the plan is ready. So let's look into this output of this file. So first is saying these are the resource that will be created. which is NIC. I think it also is showing estimated time, how long it will take for this resource to create. So what options we have provided. This is basically like the summary before executing it. So nothing much that we should be seeing, but only at the end we can see that 8 resources will be added, 0 to change and 0 to destroy. Okay, once this is done, we'll go ahead, we'll apply. Yeah, apply. So here we also saying apply, and also read this dev.tf file, because there is some dependency on this configuration file. So please also read from that file. Okay, I'll now try to increase so that we can read the output properly. Okay, let's look at the output from the top. Same, I think the same what execution. Okay, once again, where are we? Yeah, trainee, this is already we went over. Okay, let's scroll down. Yeah, apply. So here you can see slowly it's trying to connect to the Azure VM, refreshing some states, basically identifying all those dependency resources, what is needed. So it's also showing some, one good part about Terraform is it is actually, you can version your changes tomorrow. You have more modules to add, more resources to create. You can actually version them, and that way you can avoid rewriting the same resources again, but we can reuse them from the existing images. So it's showing that some changes are from outside, so it's deleting them. So that is fine. Here basically it's showing again whatever the plan showed, what all resources will be created. So we'll go ahead and we'll say input as yes. Because I'm also screen sharing, I think because there's also some slowness because of the usage of the bandwidth. So now you see the execution is started. It picked up the subscription ID to identify which under which subscription these resources needs to be created. While creating, if it's taking, it will also show how long it is taking. You can see in the first case when creating network security group, it took 2 seconds to complete. Then VM, it took 4 seconds. So it also shows the time as well, so which is good. That way you can see tomorrow when we have a more complex scenarios to execute, create multiple resources, VNet, network peering. Once those details come, we can see what is taking long and where we need to improve the code for to minimize that time lag. So now the connection to the VM is making an attempt. Oh, okay. Let's go up. I want to see if the connection is established. It's working on the connection. Okay. Okay, you can see here it's connected. So the VM got created, and also it was able to connect through the SSH port. Uh, it's saying still creating reading package. Okay, there's one error. Okay, let's look at this. Yeah, update failed. So this was something that I was highlighting. So we can try again. So in the provisioner, we had this command to basically run the sudo update. So the first command, maybe it did not get executed and it tried to trigger the second command. That's when this error happened earlier as well. So what we can do in this case is basically try rerunning the entire TM, or we can also try from here if it just try apply and see if it makes that connection, or it will try to, I want to see if it recreates the VM again, or it would just pick up from those scripts that needs to be executed on the VM. So I came across something which is related to dependency. So something, there's an option called create before you destroy. So I think I will be using that going forward in the future demos. That will basically say, hey, you have created this VM, but only some portion of the resources are created. So when you try to rerun, how do you want to handle this? Do you want to recreate before you destroy the existing one? So those are those more finer details that are also available. So we'll try to implement that in the coming demo. So you can see now it's destroying the existing ones. So what configuration that I can change later would be, okay, there's creating updating virtual machine. Let me okay, virtual machine resource AMVM resource. Okay, so it's saying that it could not find this one of the resource, which is Azure virtual machine. So okay, let me go to the portal and try deleting the resource group, and then we'll try the same again from the command prompt. Okay, we can see the new resource group, which is Linux Apache Dev. We'll delete this resource group. We'll automatically delete the dependency resources as well. Okay, we'll go to the Visual Studios. And I have seen the one behavior is, suppose say
When Apache
yes,
page is ready, you share the URL. I'll also
yes,
test.
yes, sure. So Azure Resource Manager, this is how it handles scenarios. Say there's two requests coming at the same time to create VMs. So Azure Resource Manager basically only accept one request and creates that VM, and it will deny the second request. That means we should also be automating in a way that the whenever it fails, we should try reattempting to create that resource. Sometimes it can be just the availability, and sometimes it can be because of there are any um, update domains on the physical virtual machine that might basically reboot our VMs. In that case, the VM won't be available, and we won't be knowing ahead of time that the reboot is happening. So based on that availability, um, those VMs will be rebooted without our notice. In that case, we'll basically should automate to reattempt to create this. Okay, let's go. We'll see that the deletion is still in process. If we go ahead and try to execute the apply, it will throw an error that both commands cannot be performed at the same time. So I'm not going ahead, but I'll be waiting for this um, deletion of this resource group to complete. Yeah, so this is one uh, options that we have in Terraform is also to consume the same module in another configuration file. So instead of say tomorrow there's one more request from developer saying I want similar VM to be created along with Apache, we don't have to um, recreate everything, but to consume that existing module, we'll give it a proper name, we'll keep it um, independent of each resources, and we will say, hey, now I want to create this similar module, but for a different environment, so we can do that. But whereas in ARM templates, that's one limitations where you will be able to create these resources, but you won't be able to keep track of the changes. You can modify the resource, but you don't know when was the resource modified. So that way it becomes hard for us to uh, basically track the previous historical changes. Okay, it said it deleted. So let's go ahead. Okay, now I will try to attempt the same. Hopefully this time the update runs. Unexpected status 404 resource group not found, could not be found. So let's try this. We will apply, because before apply we'll run the plan. Oh no, we'll do the refresh. We'll do a refresh. Maybe because the state file has some previous details, so maybe it's trying to pick something from them. We'll do a refresh and then try generating. So this will basically refresh, would clean up any traces of previous intermediate stages all as well. That way we won't come across this error that we haven't seen earlier when we are when we perform the initialization and apply, but now it's coming up. That means it has some intermediate states. So refresh is done. Let's run the apply again. Okay, enter a value. I'll say yes. We should be able to see also the IP address now once a VM is created. So if it fails now while executing the script, for the benefit of completing this demo, I'll just connect to that VM from the SSH, and we'll execute those two scripts. Showing the time, 10 seconds, 20 seconds. VM is still creating. You can see this time it's taking a little longer time than earlier to create the VM. So you can see that it has a specific time interval for every 10 seconds. It's updating that I'm trying to create this VM. Okay, connected. You can see we got the host ID. Okay, let it run. So now it was able to connect to the virtual machine through SSH, and it's trying to read the packet list. Okay. Reading DB. I think it was able to run the sudo update this time. I can see now it's installing the Apache 2. So as part of this script, you can also write some output or echo statements, basically letting us give proper updates. Tomorrow, we don't want all information to be readable, so we can hide some of those details and we can only see what is required. Okay, it says VM creation complete after 2 minutes, and Apache I can see is also enabled and it's up and running. Let's connect to this virtual machine from our browser and verify that this installation is complete. Read package, reading package, will read from here. Okay, so this is the address. So we'll go to the browser. You can also try on your side, Shanti. I'm gonna paste it here.
Yeah, where is the page? The page?
Yeah, I'm showing it from the
Share
browser.
it to me also. I will test.
Yeah, I ping you the IP address.
1 minute.
Yeah,
No, you
so
share that.
yes, I
This
put
one.
it on the chat.
Okay.
Yeah, so I can see the Apache is installed now through
Yeah, it
Terraform
is working from my
process.
side also.
Okay.
Good. It is done right now, both sides.
Yeah, this is done.
Now,
Yes.
can you show me the destroy option by destroying all the services, resources?
Okay, after creation, that's something I haven't set up, so I only have creation.
No, you don't need to set up. You work. You are in Terraform shell, right? Command
Yeah,
line, right? So there and destroy. There is a TF destroy command, right? You know that.
CF destroy. I have tried refresh, but would clean up. I can do
Did you not
TF,
work with TF destroy, Terraform destroy?
not yet.
Huh?
I haven't executed as part of this demo. No.
Hmm. You have run the scripts from here only, right? From this
Correct.
folder only, right?
Correct. Correct.
Then try Terraform destroy.
Okay.
Takes some time.
Okay. So this would delete all the resource groups, VMs that we created. And
Now, whatever you have created through the script,
yes.
IAC, it is going to work for destroying that.
Mm.
That particular script. That's the.
Okay.
It worked for creation, right?
Yes.
When you use it init and
Init. Yes.
after init, what command you use to run the script? Apply.
Correct.
Terraform apply, right? The
Yes.
same way destroy is going to work in a reverse way. See the comments. Is it destroying?
Refreshing state, refreshing. Not yet. I think it will. It's trying to identify all those resources.
Don't stop.
Yeah.
In Azure, with Azure, it takes some time.
Yeah. So plan, it says, do you want to destroy all resources? Say yes.
Yes. But you should have executed the script from that folder. From the same folder, you need to work with the destroy command.
Correct. Yeah.
Because you are registering that particular script using the init. Okay. Then later you are running the script to create the environment. After that, you tested it, you verified it. Then now you can apply destroy Terraform. It means automatically it takes the same IAC code from that folder.
Right.
Okay. It's working still?
Yeah. So are you able to see my screen now? It's asking to.
1 minute. I need to
a prompt.
This one view.
I
Hold
try
on.
to maximize the screen.
Yeah,
so
please.
Yeah. So now it's saying, do you want to destroy all these resources? I said yes.
Yes.
Okay. So now that this takes away that manual effort of deleting also from portal.
Yes. You take any kind of script, the process is same. It is very easy to destroy with Terraform script where you apply it from that folder.
That's good.
It's working.
Yeah, now I can see all the resources will be destroying.
Yes, you clean up everything.
Yes.
You don't need to spend much time to destroy them, right, manually.
Yes.
So you show the demo. After that, you destroy it. That's it.
Okay.
It takes longer time to destroy manually.
Destruction complete after 12 seconds. That is for public IP address. It took 12 seconds. VM, it already destroyed. It took 21 seconds. It took 11 seconds to destroy NIC. It's destroying resource group now. Yeah, so yeah, I think this should be the last.
So at the end of automation demo, in every demo,
Mm.
you need to remember use destroy command.
Okay.
You have to show that at the end. Remember that.
Sure.
Then you go to the portal and show there are no existing created resources. That is
Right.
the proof.
Mm.
Your script is working for that.
Correct. Still destroying. Yeah, destroying takes. Is it the same time in AWS also? Does it take the same time to destroy?
No, AWS is faster than this.
A little faster. Okay.
Azure only slow because it takes a lot of security scans.
Mm.
See, with AWS, you have direct access with IAM role and access with the account ID directly. But here, after entering into the account ID, you have research group access, you have so many access. It verifies all those things. That takes some time.
Okay.
And whatever command you are executing through Terraform, every time it authenticates
Mm.
each code snippet to create it.
Mm.
In AWS, it is not like that. Once you are connected to AWS, it works continuously. That is the reason it is faster.
Yeah.
The process is different, communication process.
Correct. Still destroying the group. Yeah, I was going over the document that you gave on Terraform. It's quite it's a good read. I was able to understand those module levels, what
Yes,
all.
yes,
Yeah,
yes,
TS files. You shared that yesterday, so that was a good read.
yes.
I went over half. I'm still halfway through it. So because I felt ChatGPT, I can't fully trust for the entire solution, but it's only like you can say like 80% of it is right, and you have to.
See what they do, these tools normally.
They
Earlier, you are working with Google search, right?
correct.
In the Google search, you used to get limited number of links. First 10 links you are going to consider it, you are going to study them in depth by spending hours together
Correct.
or days together. Then you are going to compile them into one solution. Here, ChatGPT is bringing one solution, but that solution is correct or not, we don't know unless you test it. In the
Right.
past, also, it is the same solution we used to spend for testing, right? Apart from compilation, it used to take more time, content
Right.
compilation. Then now that time is saved. That time is saved to below 1 minute.
Okay.
Instead of days or hours together, we used to spend to collect the content
Correct.
from different sites.
Correct.
Okay. So that is the savings. But ultimately, it is going to bring some kind of solution. That solution you are responsible to understand and test it. It should not be like, oh, it is going to give a direct solution. You execute that as a software or something. ChatGPT won't prepare any software. or Gemini, either Gemini or ChatGPT or any other tools. So they give some kind of clues to work faster. That's all.
I felt Perplexity. I'm more inclined to use Perplexity now than ChatGPT.
No. ChatGPT has got intelligence. Flexibility brings the content as it is and dumps with links, proofs. That's all.
Okay.
ChatGPT LLM and Gemini LLMs are related with development, technical thinking. For flexibility, whatever you are asking, it will not think. It will bring from the sites that kind of thoughts.
Okay.
That's all. It compiles that site's content and consolidates it and writes it there. That's all simple.
Okay.
You work more with these tools, so then you will come to know how to handle your work.
Yeah. Okay. So this is still running. I see.
Let us leave it.
Okay.
Let us stop recording now.
Okay.
We are done.
Fine.
We are done our work, right? I'll stop.
Yeah.